So a very common pattern in software development is the usage of caching behind APIs. So users will come in, third-party users will come in, and they will hit your APIs. And typically without a cache, your API will directly call to some data source. That data source could be a database like MySQL or Postgres, or even another third-party API. For example, maybe you're using Google Maps API to search places or things. And maybe you're using Yelp's API to get reviews on restaurants for your users. Um, but as you scale an API up and you get more and more request volume, you're going to start getting more and more latency and performance issues from your data sources. If you're using a database and you have thousands and thousands of reads coming in, maybe it's not able to scale with that. Maybe it's not able to handle that. And you'd either need to add on replicas of your database or put a cache in front of it. If it's a third-party API, maybe you're hitting Google Maps API, you might start running into latency issues, and also you'll run into rate limiting, right? So they'll limit you to maybe 1,000 requests a minute or some amount of requests per second. And if you have thousands and thousands of users on your application, you just won't be able to make that work. You'll get rate limited, and your users will be upset from that. So a common solution that comes in is caching in front of these data stores. User makes a request, your API first talks to a caching layer. One of the most common ones we'll be using it today is Redis. So your API will talk to Redis and see if the query is already cached. If it is, it just quickly returns that response back to the user. There's typically an expiration time on these caches, so values in there don't live forever. They'll live for whatever you set them to. It could be 15 seconds, it could be 1 hour, it could be 1 week. You choose how long you want, you choose the TTL, time to live, in your cache. You choose that value. So if it's cache miss, you will actually make that call to your data source, but before returning it to the user, you'll cache it first. You'll save it. So the next time the user returns or another user has the same query, you'll hit the cache first, and you'll save a lot of latency, and you'll reduce load that you're putting. You'll reduce the load and strain that you're putting on your data sources. All right, so let's get started. So our API that we'll be building for our data source, we're going to be using a third-party API called Nemenitem, and we're going to be caching its results and returning them for our users. So you could use many types of data sources. You could use a database, something like MySQL, Postgres, or even MongoDB, or your data source could be some third-party API that you just don't want to put a bunch of load and unneeded strain on, right? So it could be an external system, and you might have rate limiting in place there, so you can only make a certain number of requests per minute or per second or per day. So caching is really useful in this case, especially if your users are going to be searching a lot of the same stuff. So Nemenitem provides some nice API documentation, and just for today, we're going to let our users search for places. So we can pass in, for example, this base URL here, and our users can type in a query. They can give us a query here, which is basically just a free-form text string to search on, and we can specify output formats from Nemenitem so we can get back a JSON response to return to our user. So let's get started. I have just an empty folder here. Let's set up some things here. We'll need a main.go. We'll need, for deploying and local development, we'll use Docker and Docker Compose. So we'll need a Docker file and Docker Compose. And then finally, let's just set up this up. So go mod init, go Redis demo. We'll create a Go package here, our module. All right, so in main, let's set up a simple HTTP server. So Go does have some really nice third-party open source libraries. Mux and GoChi would be some of these, and here's an example of kind of how you use them. You'll set up a router. You can use things like middleware for logging or authentication, and then you just set up your handlers. But today, just for simplicity, we're not going to use either of those. We'll build using the standard library. All right, so let's get started. Let's set up a main function here. And main, let's go ahead and log out, print line, starting server. And let's get started on this. So we'll set up a handler. So I believe handle func is what we want. Yep, registers the handler function for the given pattern and needs a handler with it. So we can say pattern, we'll just call it /API, and for our handler, we'll just have a general handler. We'll need to declare that function, that handler, and it takes a specific kind. It takes a specific kind of function here that needs to have a response writer and a request object in it. So we can copy these over. And this is R, and we'll call this W. All right. And then here we can just return null. Well, let's have a log line, format.print in the handler. All right, so now we've set up our handler. Now we actually need to start our server. So we can say http.listen and serve. And that's just it. That's literally how simple it is here. So let's look at the documentation here. Listens on the network address and calls the server with various handlers. It says here the handler, this parameter, is typically nil, in which case the default servmux is used. So we're going to use that default servmux here. So let's start listening on port 8080, and we'll use their default handler. So that's all we need to do here. And let's test this out. We should be able to just run this really quickly. Go over to main. And we see starting server, and then let's curl that. So we can say localhost, yep, 8080 API and verbose. So we see here, we get logged out in the handler above in our server, and then below we just get an empty 200 OK response back. So that looks good. All right. So next, let's set up a little bit more with our response. Let's set up how our response is going to look. So to do that, let's make some types here. So we'll call it API response. And this will be a struct. And right, we're caching results. So we do want our users to be able to see if it's a cache hit or a cache miss. So let's put that in. So this right here is just a Boolean in the response, and it'll be true or false based on whether or not we hit the cache or not. Finally, we'll have some data, and it'll be something. So let's figure out what exactly we need to put in data. So this data object is literally just going to be the response from Nominatim. So let's take a look at what Nominatim looks like here. So we can do curl. We'll paste in their base, give it some of this here. We'll paste in their base URL, and our query can just be San Francisco, and we need a format equals JSON. Let's take a look at this. So we have an error here. So it looked like when I pasted this in, this kind of messed up. So Q equals San Francisco. Yep, let's try that. All right. So we get the output from their API response, and we have an array of these objects. So it's a list of all of these objects here, and these are like places, right? So we get things back like San Francisco, city and county, San Francisco, zip codes, all of that. So what we want to do now is convert this into a Go struct. So how do we do that? JSON to struct. There's a really cool website out there here, JSON to Go, and you can paste in any JSON object, and it gives you back this auto-generated Go struct, which is really nice to work with here. So let's paste that in, and let's change this to Nominatim response. Let me make sure I spelled that right. Nominatim. Yes. All right. So our data is just a list of these Nominatim responses. Call it data. Okay, that's good there. And returning this is very simple. You just JSON.new encoder. And this encoder takes a IO writer. And it just so happens we have our writer right here, W, so we can pass that in. And we can call the encode function. And encode takes some interface and encodes into JSON. So let's make that right now. So we can say resp is an API response. And cache, I'm just going to hard code these, so cache is false for now. And then data is, let's make an empty nominative response array. Okay, and then let's encode and return it. And encode does return an error, so it can error out, so let's catch that here. If error does not equal nil, that one I'm just going to use printf, so let's do format.printf, error encoding response, and let's put the error in. Okay, and let's write back header, we'll say http dot internal server error. Okay, so that's all good. Let's just run this again, test this out really quick. All right, let me JQ this. Okay, so see, still we get a 200 back, and we also get our API response. So there we go. So next, we have just an empty API response. Let's actually make this call to nominative here. So up here, let's just make a call for data is data or error is going to be equal to get data. Okay, so what we're setting up here, this is what we want to happen. We want to call some function, and this would hit our data source. That could be a third-party API, like we're doing, or it could be your MySQL database or something along those lines. But we just want to call something that gives us our data back. So let's write that function now. And this function should have a string. It should take in a query string, and it should return back a list of nominative responses and an error. So for now, let's just do nil, nil. All right, so what we want to do now is format the API we're going to hit. So we want to get our address, right? So let's do this. Q is going to equal something, and we need to have our format equals JSON. And let's give it these spaces at the start here. So Q is going to be our string here, our query string. And so if a user passes in a string, for example, like San Francisco, there's a space in the middle, and we need to escape that. So we need to have it end up looking like this. We need to escape the URL. So let's do that first. And we can say escaped Q. And Go has this built in, URL dot, let's see, query escape. What do they have here? Path escape. Let's see, let's check the documentation really quick for these. Path escape escapes the string so that it can be safely placed inside of a URL path segment. Yes, that's what we want there. I believe that's what we want. So let's see what is, whoops. Hit the wrong button. Let's reopen up. All right, so path escape, and let's see, what does this take? I believe it just takes in a string. Yep. Just takes in a string, so we can just pass in this. And finally, what we can say here, format.sprintf, comma, escaped Q. And let's make this a little bit wider so we can read all of this. Okay, so this will give us our endpoint that we want, and in Go, it's very simple to make basic requests. So we can do http.get, and this will return a response and an error, and it takes in a URL. So we can just say address here, and then we can say response, comma, error. If error does not equal nil, let's handle our error. We want to return nil, comma, error. Otherwise, we do have a response, and we need to read it now. So we need to read that response, and we need to build our actual nominative response array. So we can say data make, and we'll do an empty nominative response array. And now, just like above here, we had this encoder. We can also use JSON.newDecoder, new decoder. So that takes a reader, so we need to find the reader. And we have our response object dot body, which just happens to be what we're looking for here. It's a reader. And then we can say decode. And this, now we need to pass the address of wherever we want to decode. So we'll say address data. And this can throw an error, so let's catch that. Error equals this. If error does not equal nil, we want to return nil, comma, error. Otherwise, we've decoded our data successfully, and let's return data with a nil error. Okay, so now we have this get data. We see that it needs a query string. So to get our query string, we can do r.url.query.get, and that takes the whatever parameter that we want to get from the user, which is just q. Okay, and we can pass that in. So now we need to use data here. So now instead of just using this hard-coded empty array, we can pass data. Okay, and let's see, what is this? The value of error is never used. Let's handle that here. So let's handle the error we can potentially get. Printf error calling data source. And then let's print our error here. And I think I'm forgetting to do new lines, so let me do that. All right, print the error, and then let's write a header. Okay, handle the error. Now we're actually returning the error. All right, so that should be good. Let's test this out here. Go run main.go. Localhost API, and now we need to pass in our query. So we can do San Francisco. What do we get back? So we actually get back our response here. So this is that cached, this is that response from Nemenitum here. So we actually called their API, and it was successful, and we see cache false, and data is that large array. So we're working, we're doing things now. This is good. Okay, so we have our data source wired up here. We have our API response getting built, and we're sending the response back. Awesome. Now let's add in caching. So that's the next step here. So get data, I think that's the place that should live here. Let's do some reformatting. Yep, this looks good. So now at the start, before we make this request here, we need to check to see if we have a cached value or not. So this is where the cache should live, up at the very top here. Is query cached? That is the answer. That's the question that we want to answer here. So now is the time we revisit our Docker Compose and our Docker file. We need to actually set up our Docker Compose to run our server and a local Redis server. So let's get started. So version 3.3, you can use whatever version you want. And we're going to make two services. Our first one is going to be web, and this will be our Go service. We'll need to expose our port that we're listening on, 8080, 8080. And we'll set up environment as well. There'll be a couple things here. The first one that we'll specify here will be our port, and this is the port we want to listen on. And this is important because when we deploy later to Heroku, when you make a deployment, only opens up a single port, and your server needs to listen on that port. And it could be any port, it's a random port. So it's important that we set this up now. Locally it'll be 8080, but we have no idea what port Heroku wants us to listen on. So port, that's good here. Let's set up our Redis service now. And we're just going to pull in the default Redis Alpine. Don't need any environment variables here. Let's link these together, Redis URL, and this will be linked to Redis. All right, so that's good there. In our Docker file now, so we're building, we need to actually build, and it looks for a local Docker file when we specify this dot here. So let's set up a really basic Go Docker file. So golang Don't care about the version. It'll just take the default or the latest. We're going to make a directory to store our code and our binary that we build here. We're going to add everything into that directory. We're going to specify that that's our working directory. Finally, let's build our binary. So go build, and we're going to output that to main. And we're just going to say everything here. Finally, we'll expose our port 8080, and let's run command app/main. Okay, so this is all good here. So let's try running this now, see if we can catch any errors. So Docker compose up build. Let's give this a second here. All right, we're back and our server's running. Let's test it out. So curl localhost. Awesome. So we get our log in the handler and we get our response back. Great. Let's close this down. All right, let's get back into our application here. So we're going to need to reformat some things. We're going to need to add in Redis first. So let's do this. Redis is the library that we'll be using here. There's a few other Redis libraries out there. You can use whichever one you like or are familiar with. We'll use this one. So we need to install it. Let's run that command. And then next, so let's go ahead and bring this over. And we are going to make another type here. So let's go down. Let's call this type API. So this API struct is going to hold relevant things for our API, like our data sources, or if we had a logger, it would hold the logger as well. But for us, we're just going to have a cache, and it's going to be a pointer to redis.client. And that's it. And next, we'll have a function here, new API, and we want that to return a pointer to an API. Address of an API. Cache for now is nil. Okay, and let's add our code in here to connect to Redis. Cache will be RDB. Okay, so here's our connection for Redis here. And let's get that from the environment, Redis URL. And yep. So let's do a sprintf here. Sprintf. And when we run this locally, we need to specify the port. When we deploy, we'll have to do something a little bit different. What was it, 6379? That's the default port. So this will work locally. When we go to deploy for Heroku, we'll have to change this back. We'll have to alter this a little bit. So we're putting in our base, we're setting up a Redis address here, and this is what we're getting from the environment, from our Docker Compose. And then we're just adding a port on the end and passing it through. Okay, so that should run. Next, we need to have a way for our handler and our getData function to access this API. So we're going to add these methods now onto that struct. So a API. Same thing for data, a API. All right, that's good now. And now you see here, undeclared name handler, because we can't just call it anymore. We need to call it on a struct. So we need to say API is new API. Okay. And then we need to call API.handler. That works there. And here we need to call a.getData. Awesome, so we're good. So what this lets us do, inside handler or getData now, we can access that cache. So for example, I can do something like a.cache.get. Right, we can do things like this. And that's what we're trying to do here. Okay. So we want to see if the user's query has been cached. So you can check that right here. And this would be the example we want here. So there's a couple of different options, right? So this first error you see, redis.nil, that means the key doesn't exist. So the key wasn't found. Otherwise, it's some other error, and that's like an error with the Redis server. We couldn't connect, something went wrong behind the scenes, and that's a bad error that we want to handle. And then the third one would be the value was found. So let's check over here, bring this over. All right, so is the query cached? So we'll say a.cache.get, and this key is going to be just our query string. So this takes a context. So context in this case, let's say a user makes a request, and this request is going slowly, and it's not completed yet, but the user closes the web page, or they cancel the request. In that case, passing a context allows us to cancel the Redis query as well. So if a user isn't listening for a response anymore, we shouldn't keep trying to fetch a result. We should just cancel that request and move on with our day. That's what this context allows us to do. So let's add another parameter here, context, and now we can just pass that straight through. Now we need to add this parameter up here. So where do we get this context? Every HTTP request in Go has a built-in context, so we can say r.context. And that just gives us the request context. So if this request gets canceled midway through, we'll also cancel our request to Redis, and we'll just speed up and save resources that way. Okay, we'll change this to value. So here, this is the case if the key doesn't exist. So we want to set. In this case, we want to call external data source. Set the value, return the response. That's what we want to do there. In this case, there was some error with Redis, and we want to log it. So format printf, error calling Redis, put a new line, and then we want to return nil and just error. Okay, otherwise we found the value, and we can just, we need to decode or build response, return response. Okay, so let's handle this first case first. So if the value is nil, then we want to call the external data source. So this means we can bring up a lot of code from here. Let's just copy the whole thing, and we'll put it in there. So we just called the external data source, and now here, before we return the value, we need to set the value. So let's put this here where we're returning the response, but here we need to set the value. So to do this, let's look over here. This is the function we'll use. It's our cache.set. We give it a context, whatever key, and then this needs to be the string, the encoded value basically. So we need to convert our JSON object into like a string. And then this third parameter is going to be the expiry, how long it lives in Redis. Let's just copy this over, and we'll say a.cache.set, and we'll handle our error here. So same thing, we'd return nil and error. And the key is the user's query we're passing in, remember. And then our value, we need to say encoded data. We'll do that, encoded data. This doesn't exist yet, we'll make it. And then expiration, let's say time.duration, we'll say time.second times 15. We'll make this a 15-second expiration, just so it's quick for the demo, right? So we can query and see some cache hits and some cache misses. All right, let's encode the data here. So for this, we can use our JSON encoder. So we'll do json.new encoder. Let's see here. Marshaller, I believe is what we want. json.marshal. Yes, so this will return, this takes in some interface here, some object, which is our data response, and it gives us a byte array or an error. Okay, so let's go ahead and marshal this data, and this will give us byte, our byte or error. And let's handle the error. Otherwise, we can use this now. So we'll say B, and I believe we'll have to convert this to bytes. So new buffer string, and let's say bytes. B. Okay, so I believe we need to declare that. Cannot use B byte as string. Okay, there we go. So we want just new buffer. So we set the value now, times out at 15 seconds, and we return our response. Awesome. So that should be working. Okay. And so this is handled here if it's just another Redis error. So the last thing we need to do is handle the case when it's a cache hit. So this is a cache hit down here. So we need to build that response. So we need to say data, and let's actually build the response. So we'll do, remember, we are setting the response in this kind of marshaled encoded buffer. So now we need to unmarshal it here. So data JSON.unmarshal. And it just takes value. What does this take here? So this takes the value that we're unmarshaling, and it also takes the address that we want to unmarshal to. So in this case, it'd be value, and this should be data. And it just returns an error. So here we'll say error, but we need to define data up here. Okay, what is this? Cannot use variable string. Okay. Can I just cast this, or do I need to actually convert this? Okay, so we need to convert that bytes dot buffer string value dot bytes. Okay, and let's handle the error. So if that error is not nil, otherwise we can return data and nil. Okay, what is this? Call of unmarshal passes non-pointer. Okay, so it wants a pointer, so we need to give the address of data to unmarshal to. Okay, so it's a cache hit. So let's just review this really quickly. So now when we go to get our data, we first, before we call our actual data source, we first check our cache. So we get the value from the cache. We check, is our error equal to Redis nil? And in that case, that means we just didn't find the value in our cache. So then we actually reach out and call our external data source. We call our external data source. We get the data back here. We save it, so we marshal it up into some bytes, and then we save it into our cache, and then finally return the response. If it's just a random error from Redis, we just log that and return it. And otherwise, it was a cache hit, so we'll actually return just the value directly from the cache, and we don't even call the data source. So one thing as well, we need to figure out if this was a cache hit or not, right? So let's add on another response here, so Boolean, and this will determine if it's a cache hit or miss. So in these cases, we'll just put false, this was a miss, false, this was a miss, this was a miss, this was a miss. So this case, this was a miss here, so it's false. This was a miss here, and this is a miss here. So this one is the one where it's a cache hit, where we return true, okay? That's just a simple way of doing it. You might have a cleaner, different way of doing it without adding on this cache hit or miss variable. So up here, we'll say cache hit. So now we check if it's a cache hit or not. So this will be true or false based on what we got returned from get data. So now we just pass that through to cache hit. So that should do it for this. Let's run it and see if we can find any errors here. All right, so if you run into any errors here, Docker compose up build. If you run into any errors where it's like missing a package or anything along those lines, you can add in a line into your Docker file here, go get t, and this will add in any missing packages as well. Feel free to put this in. If you're not getting an error, don't worry about it. All right, so our server's up and running here. Starting server, and let's test it out. Curl, localhost, San Francisco, JQ. Let's hit it. And what do we get? End handler. And I just want to see if it's a cache hit or a miss. So cache, false. So now we call it again. We should get a cache hit. And we see we do. Cache, true. And we see in the handler here. So let's wait a few seconds. And let's see if we can get a cache miss. So it should expire within 15 seconds. And then the next time we call it here, let's see if it was 15 seconds. So cache false, so the value expired. Awesome. So it looks like we're working here. Yep, looks like everything's working here. One thing I realized we forgot, we're still hard coding our port. So we can change this here. Let's say os.get_env port, and let's just change this over to be sprintf. A string, so we need a string, comma, os.get_env, and missing, there we go. Missing a parentheses there. Awesome, yeah, so I think we're good here. One thing we are gonna have to change is our Redis address. And so let's go ahead and start with deployment process, and we'll figure out where we need to change our Redis address when we get there. So here we don't have any apps set up. You can create an app from the dashboard here, or you can do it from your terminal. You can do it from the dashboard. Let's jump in. I believe there's a guide right here for doing it from the terminal. Yes. All right. So this is Heroku's guide for container registry and runtime. So when you're deploying with Docker, you'll use Heroku's container registry. Heroku container registry allows you to deploy your Docker images to Heroku. So let's just follow this process here. I think I'm already signed in, but we'll just double check. Yep. All right, login succeeded. And next we can do Heroku create. This will create a application here. All right, we have our application. And next thing, we should just be able to push our container up. So before we do that, actually, realizing we'll need to provision our resource here. So we need Redis, right? Our application depends on Redis. So if we refresh our page, we see here's our app we just made. You can just go right into resources, and let's search for Redis. So there's a bunch of different options here. I'm just going to use Heroku Redis. It's the simplest. So it's free, and let's order that. And this provisioning process will take a little bit of time, so I'll check back in with you when that completes. So while our resource is provisioning, there's one last step we'll need to do. We'll need to change how we get our Redis address configured. So when we're running local, we want to configure our Redis address just the way we're doing here. When we deploy onto Heroku, we need to set this up in a different manner. So we need to have a way to determine if we're local or not. So we can set a variable here, local, and we can just say true. So when we're using Docker Compose locally, this will be set to true. When we deploy to Heroku, they're not going to set this local variable, and we'll know we're remote. So we can check that if os.get_env local is true. We want our Redis address to look like this, and we want to create some opts, right? So we want to create this here. These are our options. Otherwise, we're going to be remote, and we want to create a different set of options here. So let's bring this back up. And finally, we just want to set this up with opts. And then up here, we can go ahead and say redis.opts, redis.options. Okay, Redis address. All right, so when we're locally running, we are going to parse our address just the way we've been doing, and we're going to build our client with those options. When we're deployed on Heroku, we're going to parse it a little bit differently. All right, so we see we've provisioned our resource here, and now let's see why we need to parse this differently. So we see here we have the Redis URL environment variable, but it looks a lot different, right? There's a port in there, there's a long endpoint in there, there's also a password or a username in there as well, and there's this prefix. So Redis, Go Redis has this built-in function here, parse URL. So we can call redis.parseURL, and we can get it a long format URL, and it will let us parse in. So see, here's the format. This is the exact format we're using here, that Heroku is using. So this is kind of what we want to do. So now let's do this. Parse URL, and we're just going to give it os.getEnv Redis URL. And this returns an option and an error. So we need to say error. And let's handle that error. We're just going to panic here with this error. What is this complaining about? Undeclared name. So we can declare it there. And we'll set that equal. All right, so we should be good to deploy now. And yeah, let's go ahead and deploy this. So if we go back to the Heroku guide here, we've created our app. So now we need to build the image and push to our container registry here. So let's run this command. And then after that completes, we will run container release. And we have a missing app. So we just need to pass in the app name, which is this. So we can do this -a and then pass in Peaceful Depths. All right, and we've successfully pushed it up, and let's release it. So this should release that image we just put up, and now we need that flag. Let's get our app name again. And also, while we're here, let's find our base URL. So this is where we can call our app. All right, so we just released that, and now we should be able to curl that endpoint /API, and then we give it query San Francisco, and let's test this out. All right, and we see we get our result back. And let's check our cache. So cache is false, and let's rerun that query. And we see caching is true here. Awesome, and we can rerun this one more time once we get to 15 seconds. I think it's been about 15 seconds. Run it again. Yeah, cache is false. And cache is true. Awesome. So there you have it. We have built out a just a proof of concept, a simple API in Go with a very simple Redis cache. And this code is not the cleanest, and it's definitely not production ready. That's not the goal we're trying to do here today. We're just trying to get a proof of concept and some basic app for you to hopefully take away some new ideas for your product or whatever you're working on. A good problem to have is having a bunch of users and needing to refactor some of your code to productionize it more, having your clients asking for better performance and needing to scale. That's a good problem to have, right? And that's typically when you'd move off of Heroku and onto a bigger cloud provider like AWS or Google Cloud or Azure. But a bad problem to have is spending tons and tons of your dev time on setting up your complicated infrastructure and productionizing all of your code before you even have a product and before you even have a customer. So that's really, I highly recommend, just for ease of use, using technologies like Heroku or other just quick out-of-the-box providers where you don't need to configure a lot of things. Things are wired together quickly. They just work, and you can get up and off the ground running. So hope you learned something today. Hope you enjoyed this. Please make sure to like and subscribe and comment on these videos. Lets me know I'm doing something that you value. And if you have any suggestions or things you'd like me to cover in the future, leave a comment down below.